Ladies and gentlemen, welcome to the second Insight webinar, a webinar focused on energy optimization of industrial compressed air. It's a joy to have you on board, and with these webinars, we want to build awareness on the energy savings available in compressed air systems and share some experience on how to reach those potentials. There is now a growing focus on sustainability topics, and of course, initiatives like the Paris Agreement, United Nations Agenda 2030, and the recent COP26, they are all making an impact. So you can say the time is now. There has never been a better time to address energy optimization of industrial compressed air. At Enersize, we do want to contribute to a more sustainable world. And we do this by supporting this kind of energy optimization. And we have the ambition to become a global champion of compressed air efficiency software. But now let's look at today's agenda and what different sessions we will see. So, after the introduction, I will hand over to two of the world's most experienced experts on compressed air, our technical director, Mr. Bo Kuro, and his friend and colleague, Mr. Ron Marshall from Canada, who is the most famous rock star of compressed air in all of North America. We will also meet our team lead from research and development, Rebecca Rubio Lopez, and she will, together with our CEO, Anders Sjögren, be looking at the roadmap and where we are investing from a product development perspective. Finally, we'll be sharing some of the upcoming initiatives before we end today's session, and we will also meet Enersize Academy's head, Johannes Olsson. But now, it is a joy to introduce a couple of true thought leaders and experts on compressed air. Our technical director, Mr. Bo Kuro, who has worked with compressed air in over 40 countries, representing both the United Nations as well as the World Bank. And together with him, our partner, Mr. Ron Marshall, who is the North America's most published writer on compressed air optimization. He's a leader in the US Department of Energy's initiative Compressed Air Challenge, and as Bo, a very experienced field expert working in many countries around the world. So the topic of today's session will be what happens when compressors fight. And I let Bo Kuro introduce us to the topic. Please take over, Bo.
Okay, thank you very much. I will start this subject we have today with a little introduction on how different types of compressors they are controlled. This graph shows from our X-ray system, cloud system, and it shows one compressor in operation out of 4. Maybe I should start to tell a little bit about what we see. The red line on top here is the pressure. The dotted line is flow, and the flow, you can read that on the right side, and the pressure on the left side. And then we have these 4 different compressors. When we are gray, it means that the compressors, they are stopped, and if they are green, they are running in loaded mode, and if they are yellow, we are in unloaded mode. So obviously only, I think it was Saturday or something in the evening, obviously only one compressor is in operation, and it goes on and off depending on the pressure. The pressure settings in this compressor could very well be from 5.8 to 6.4, and it means then the pressure goes on 5.8, the compressor will start generate compressed air, and it will continue until it reaches 6.4 bar. The reason why we can control compressors with pressure is that if you generate more compressed air than you consume, then the pressure will increase. And if you consume more than you generate, then the pressure will drop. And that's basically the way we control compressors. That was fixed speed compressors. With the variable speed drive VSD compressors, it is a little bit different, not much, but a little bit. We still have the lower limit pressure or the load pressure, and then the unload or the upper limit pressure, and then we have something we call target pressure. And as long as we are in the VSD mode, and VSD mode means for a VSD compressor typically from 100 and down to 30%, then it will try to stay on the target pressure and speed up and down according to the demand. When it reaches the 30%, then it will start to operate as an on-off compressor. And that is basically what creates the control gap problem or issue. But that's the way it is with VSD compressors. Different master control systems. Here is one from Air Leader, where you can see the master controller controls each individual compressor based on pressure measurement in the receiver. And then, as I mentioned before, then we take in and out compressors when we reach the upper and lower limit in the pressure band. But the master control will try to stay on the target. Now again, we are back in our X-ray cloud system. As you remember, red line bar, dotted line flow, and green means running, yellow means unloaded, and gray means stopped. And you can see on top we have the VSD compressor. Remember, the VSD should preferably be always the first one in and the last compressor out. And this is also what happened here. We are running these VSD together with 3 fixed speed compressors on top of everything. The VSD will speed up and down according to the demand, and then we call in or send out fixed speed capacity accordingly. So this is pretty much the way it should work as shown here. Thank you.
Well, thank you very much, Bo. That was a highly interesting presentation. It's a pure joy to have Mr. Ron Marshall joining us today, all the way from Canada. And Ron, please take the stage and share your screen.
All right, thank you very much, Anders. Yeah, my topic for today is control gap when compressors fight. And I see this this problem a lot. These days, variable speed drive compressors are quite popular, and they require some different settings and different sizing rules so that they work properly. So in order to be efficient, VSD regulation over the complete range of compressors profile must be continuous, and the VSD should be operating nicely between its minimum and maximum settings. And if that's happening, then you'll have a really nice system that's efficient from 0 to 100% capacity, 100% capacity being the total combined capacity of your compressors. So this chart shows kind of an example of what should be happening with a variable speed drive. So we can see this orange dotted line is the flow on the system. So in the first instance, only one compressor is required. So that compressor is a variable speed drive. If the variable speed drive doesn't have enough capacity, then a fixed speed compressor is switched on, maybe perhaps a bigger fixed speed for larger loads, and maybe two fixed speed compressors for very high peak loads. And then you can see as the load comes down, uh, the fixed speed compressors are removed from the system, but the VSD is always remaining running. And that's the way you want to operate the system. And to achieve that, you need a little bit different compressor settings from what is normally seen in a multi-compressor system. Now, a control gap happens when the variable speed drive compressor is not sized properly compared to fixed speed compressors. So the rule is that the variable speed drive compressor, the variable part of the variable speed drive compressor, must be equal to or larger than the fixed speed compressor with which the variable speed drive must work. So this is kind of a complicated chart. We can see airflow, and this pink and red bar is the variable speed drive compressor, and the blue bars are all different load points. So we can see this this variable speed drive compressor has this pink area is the variable part of the variable speed drive compressor, and the red part is minimum speed. So with any variable speed drive, you have an adjustment range where it's speeding up and slowing down, but it can only slow down so much. And then below that, it has to start and stop, and that's actually not a recommended range of operation for a variable speed drive. So in adjusting for different flows, we go up and down here in the pink region, and we stay away from this red region. So we can see here this load condition, we're in the variable range. This one here, we're in the variable range. But what happens when we get to above the capacity of that variable speed, we need to switch on another compressor, a base compressor, because there's not enough capacity for this variable speed drive. So if we switch on, and in this case we've got a variable speed drive compressor is 200 horsepower or 160 kilowatts, and it's working with equal sized base units. When we switch on this base unit, we can see that this base unit, the capacity is more than this variable range. We get to a point here where there's a control gap. So anytime we're within the control gap and the control gap is equal to this minimum speed, then the compressors will fight. When they're fighting, the variable speed drive will come on. It's not enough capacity. The fixed speed compressor will load. It's too much capacity when we add in the minimum speed flow, and the compressors fight. So there'll be too much capacity, not enough capacity, too much capacity, not enough capacity. So the VSD will be speeding up and slowing down. The fixed speed compressor will be loading and unloading, and that's an inefficient operation within this control gap, right? So in this case, you know, they've set up okay, there's a percentage of time where in this system we're operating at various flows. Within these flows, here, here, and here we've got control gap issues. And the rest of the time, the system is operating nicely, right? Because the control gaps are actually in a band, right? Below the control gap, everything works nicely. And above the control gap, everything works nicely. And if we had a third compressor come on, we would also have a control gap up here of the same width, right? So that's kind of my explanation of a control gap, right? And if we want to properly control these compressors, we need to size the fixed speed compressors properly. So in this case, instead of 200 horse fixed speed compressors, we've got 100 horsepower or 75 kilowatt. In this case, all conditions we can see here, when the load gets above the variable speed drive, a 100 horse fixed speed compressor comes on, and in all conditions, everything is satisfied. Here's 2 fixed speed compressors. Everything is satisfied and there's no control gap. So that's a good way of operating the compressors. So this is the traditional pressure band for multiple compressor systems. We can see this is a 4 compressor system, and we call it a cascade arrangement, where this is the lead compressor. The first compressor comes on, and if that's not enough, the second compressor comes on, the pressure drops. If that's not enough, the third and the fourth. So it's kind of a stair step or cascaded arrangement that's working with the compressors. But this type of arrangement is not suitable for variable speed drive compressors, unfortunately. We have to look at other ways to control the compressors. So the compressors might be tied in with a communication network or a compressor controller, and it's very important for those compressors to see the same pressure. All the controls of the compressors are seeing the same pressure, and the pressure signal is taken off after the air treatment, because this represents a pressure loss, right? And if this is done, then you have nice regulated pressure here in storage exiting the compressor room. So when setting up multiple compressors with VSDs, we have to nest the VSD set point within the bands of the other fixed speed compressors. So we can see here it is kind of a cascaded arrangement, but we've arranged it so that this is, we can see, draw a line all the way over here, and here's the highest load point. We draw a line over here, and we can see the VSD set point is nested within a band within all the compressors. So then if our VSD set point is usually slightly lower than the halfway point, and the indirect stop of the VSD being larger than the fixed speed units, is higher than the highest load point. And if we set it up that way, then the VSD compressor will operate adequately. It will always be the lead unit, and if sized correctly, there will be no control gap. So we want to make sure that the VSD is always the lead machine, that is correctly sized, so the variable part is equal to or larger than the fixed speed compressors with which it must work. And we need properly sized storage capacity. Storage capacity is important to make sure that when we're switching compressors and loading and unloading compressors, that the pressure doesn't fluctuate too much, too fast, and slowing down pressure fluctuations requires some large storage capacity. And we need good control strategy, so sensing the pressure downstream at a single point so that all compressors can see the same pressure. It's easier to control the compressors that way. And that brings me to the end of my presentation. Thanks very much.
Well, thank you very much, Ron, and we will continue to speak about compressors and about what happens when compressors fight. So it's great to have you here, Bo, and I'm looking forward to hear what you are presenting today. Screen is yours.
Okay, thank you, Anders. I will talk a little bit about the control gap problematic or issues you can have. Let's take a look a little bit deeper into what it is. If you take, for example, Atlas Copco, you take the GA oil-injected 160 kilowatt compressor. We go for an 8.5 bar machine. Then you will see that this one fixed speed compressor can deliver 29.1 meter cube per minute. We go into the similar data for GA 160 VSD. We have it here again, 8.5 bar. And if we look into this capacity according to free air delivery, FAD, then this compressor can go minimum 9.2 and up to 30.4. If we try to put these numbers into our developed control gap tool, where you can see I put the minimum output from the VSD in the top. We are again dealing with an Atlas Copco GA160 VSD. I put the 9.2 minimum and the maximum was 30.4. You remember from the manual or from the brochure. And then we have the other one, which was an ordinary oil-injected fixed-speed compressor, same size as you can see, or almost same size when it comes to capacity, 29.1. These number, we put these numbers into our control gap tool, and the result will be like this. You can see when the blue line is above the orange line, then we are dealing, then we have the control gap. And this control gap will be from the capacity 30.4 up to 38.3. Let's try to look into a little simulation of what is going on when we are talking control gap issues. I have here a situation where you can see from midnight up till almost 8 o'clock, we have a flow profile that the VSD compressor can take care of. But just before 8, we will be in this situation. We have maybe the 70% speed on the VSD motor. And we will see a few minutes later, we will be in a situation where we will need help from a fixed speed compressor. And that will be here. We will put some settings where we, in this case, just an example, I have put compressor 1 on load or when it goes loaded on 6.7 bar, and it goes off 7.5. The VSD target is 7.1. The VSD will go on 6.9 and off 7.7. Let's take a look what will happen. You see the fixed speed compressor will go on, or actually first the VSD motor will go full speed, try to handle the situation, which is not enough. And the compressor 1, similar size, will go on. And now, as you can see, we have actually too much air available, which will do that the compressor will, or the pressure will increase. And you can see up to where we turn or put the fixed speed compressor in what you can see unloaded condition. We are here in, we have the minimum speed for the VSD. And next, we are in this area, as you can see, the control gap area, as we call it. And the next thing that will happen is that the compressor 1 will go off or unloaded. And remember, unloaded means that the fixed speed compressor will still continue to consume in the region of 25% energy, even it doesn't contribute at all to the generation of compressed air. We are now in a situation where we have the VSD minimum speed. The VSD is now all by itself again. It will try to speed up, but shortly after, the compressor 1 will have to go on again because we simply have too little air available. So that next will happen. We have seen that before. It goes on. We go on a VSD target. We are again on too high pressure, and that will continue basically forever as long as we are in the control gap area. And that was not the intention when you bought a VSD compressor in combination with a fixed speed compressor, that you will have basically a VSD compressor going on and off. Same with a fixed speed compressor. And but the fixed speed compressor will consume in unloaded condition 25% energy, and you will have a lot of pressure fluctuations. This is, can I say, control gap in a nutshell. This is what we will get if we buy two same similar sized compressors, VSD and fixed speed. And it doesn't really matter if we have more compressors. This was just an example. And let's take a look. How will it look in real life? I will just show a little video about what it is. Yes, as you can see, what you saw here was actually the first compressor was a VSD, or is a VSD compressor, and you could see compressor number 6, which is a fixed speed compressor going up and down from loaded, from loaded to unloaded mode, and then consuming 25%. And you can imagine that a compressor in the size of 400 kilowatt will still consume a roughly 100 kilowatt to basically doing nothing. Thank you.
So thank you so much for those presentations. And I just want to have a little conversation with you here, because we have received some questions from customers that would like to take the opportunity when we have both of you in the room to get some answers. And the first one is, my variable speed drive compressor is running at 75% loading at night and on weekends. What could be causing this? Can you please start this, Ron?
Sure. That's very interesting that compressors loaded that high during the weekend. Very often with normal production activities, there'll be production during the day and nothing at night. And a variable speed drive running at 75% might mean that you have a high level of leaks, something to be investigated.
Thank you for that. I have another question here I think is suitable for you, Bo. I think VSD compressors are too expensive and complicated. Are they really needed?
Well, they are not really needed with a lot of number of fixed speed compressors and a very good control system, you can almost get the same good results when it comes to efficiency. Complicated? No, I will not say they are more complicated. More expensive? Oh yes, they are more expensive, 30 to 40% more expensive. And this is why if you want to go for a VSD compressor, you should only buy one and run this in combination with your fixed speed compressors. So two things. You go for one that will give you okay savings probably, but remember a VSD compressor is less efficient running a full load compared to a same size fixed speed compressor. And the second thing, if you want to go for VSD, then remember to buy it bigger than the fixed speed compressor you combine it with. Otherwise, you will end in the control gap situation. And also, I must add, no fancy, sophisticated master control system can fix that problem for you.
And I just wanted to add to what I tell my customers is if only the VSD is running, you might save on average 30%. But if you've got a second compressor running with it, the savings on a well-controlled system is 15%. With add another one, it'll be 9%. Add another one, the savings get less and less. So what Bo said is definitely correct. With a proper control strategy, you can get with lots of compressors, multiple compressors, very good savings without a variable speed drive compressor.
Well, I have a question here that I think maybe you answered in the presentation, Bo, when you talked about the tool. The question is, I have a variable speed compressor. How do I tell if it's operating properly with my other compressors?
Yeah, well, we can test it. You can look into the technical specifications for your compressors, and if you can provide us these data, then we have this control gap tool where we put in this data, and then we can actually see right away if we have a control gap between the VSD compressor and the fixed speed compressors. So that's one thing you can do. Especially you should do it before you go and invest in new capacity. That can be a very costly affair not to do this investigation before you buy a compressor. Remember, a compressor it is a pretty expensive piece of machinery,
Yeah.
I will say. So please spend a little time, maybe together with an expert or a consultant, and try to look into this problem before you go and buy.
Yeah, and just to add to that question, both Bo and I are professionals that measure compressed air systems, and I would say if you want to know if your VSD is working properly, measure your system, right? Do an audit of your system. And one of the first things that I do is I go and take a look at the compressor controller. And inside the controller, very often there'll be a histogram or set of hours that can tell you if that variable speed drive is operating in the variable part, or sometimes they're just locked on full load. And as Bo mentioned, fully loaded VSD compressor is not efficient, not compared to a fully loaded fixed speed compressor.
Thank you. And before I will ask my final question to you, both of you, and ask you about your experience of what happens in the field when compressors fight, I just want to ask, at what point do I need to consider installing a compressor controller? And maybe you can go for this, Ron.
Yeah, usually what I say is if you've only got two compressors, one VSD and one fixed speed, you really don't need a controller. Maybe add a second one as it starts to get harder, right? Remember my diagram where I had the pressure settings cascaded a little bit and you had to fit the VSD within the overlap. It gets to be more and more complicated to do that as you add fixed speed compressors. So I would say 3 compressors or more, one being a VSD, it's a good idea to look at using a controller.
So something happened with your bandwidth there, Ron. Your image is slightly blurry and your voice was lost. So maybe if you can redo
Nice.
the final part.
From what point?
From the last comment. So the last answer. At what point do I need to consider installing a compressor controller?
Yeah, I normally tell my customers, if you've got more than 3 compressors, one being a VSD, you should start to consider a controller, right? Remember that cascaded arrangement where we had to fit the VSD within the overlap of the multiple fixed speed compressors? Well, as the number of compressors gets more and more, it becomes more difficult in fitting that, controlling the compressors properly. So usually, 3 compressors or more, you should use a compressor controller.
Thank you so much.
Maybe I could just add here that please remember, if you buy the wrong sized compressors VSD, not even super sophisticated master control system can fix that problem. It is not the cure. It is correct that I will also say, as Ron, I fully agree that 2 to 3 compressors without, if you have more, get a control system. But a control system is not the cure to avoid control gap. Remember that.
So my final question now before I let you go, guys. Please tell me something of what you have experienced from the field when compressors fight. Who starts?
Well, I can start. Well, I had this little video from my presentation. If you remember that, that is really an example on what can go wrong. You have 6 fixed, no, sorry, 1 VSD and 5 fixed speed compressors. You have a control system. You have everything, and they start to fight. And why? Because simply because the VSD compressor is too small compared to the fixed speed compressors, and it means that you end up in this mess where you have pressure fluctuations. You have VSD going up and down in speed, and you have more or less permanently one fixed speed compressors running in unloaded mode. And in this situation, it was actually 400 kilowatt compressors. So that compressor running in unloaded will take 25%, means 100 kilowatt for doing nothing.
It's
It's quite a lot.
quite a loss there, quite a loss.
Yeah.
And Ron, some quick words from you. I know you need to go.
Sure. Yeah, I can think of 2 situations where compressors were fighting. One I'm dealing with right now, a large mine. It has 14 different compressors, and they decided to just set all the settings exactly the same so that the compressors are running at random. So there's times where they have too much pressure. There's times where they have too little pressure, and basically the whole system is really inefficient. This system actually consumes $4 million per year in electricity costs, and they even have compressors running on diesel, which was 3 times the cost of direct electricity. So a lot of waste. I figure very close to $1 million worth of savings could be had in properly controlling the compressors. A second one is a sawmill where they purchased properly sized VSD, 110 kilowatts, to run with a 90 kilowatt fixed speed, but it didn't operate properly. In fact, it only ran for 10 hours before there was mechanical problems. And I got the customer to send me the compressor settings and the compressor hours, and I could see the compressor settings were incorrect, not set up properly by the the compressor technician, and that could have caused a mechanical problem with the system, and definitely the system was running inefficiently in the short period of time it was operating in. So sometimes the people that set up the compressors don't know the proper way to do it. It's best to consult an expert to make sure that your compressors are running properly.
Amazing. Huge savings to be done. Well, thank you very much, gentlemen. I'm looking forward to the next opportunity to meet both of you again. Have a great day, and we are moving on. Already in the 19th century, Lord Kelvin said, "To measure is to know." And this, you can say, is the fundament of everything we do at Enersize. In other words, we believe in data-driven decision making. And when we are helping customers with energy optimization of their compressed air, we always start by creating a baseline with what we call X-ray. We install mobile battery-driven loggers in the plant to measure pressure, current, voltage, dew point, etc. And we upload the data to our cloud database for analysis. With this, we are, in a scientific way, able to establish the initial energy baseline, defining the true energy cost level for running the compressed air system. We are also able to present the savings potential and a detailed action plan on how to reach that. In the next step, we carry out a leakage survey and a repair project to reduce the waste. When the project is finished, we deliver a confirming system analysis, and once again, we are utilizing the mobile loggers to get the scientific definition of the new energy cost level. We call this service, all in all, leakage reduction. And from this moment, we implement continuous monitoring in the plant to be able to follow the compressed air system in real time, and to take data-driven decisions and help customers institute a sustainable energy optimization of their compressed air system. The ambition is to monitor and maintain the new energy cost level, or to reduce it even further. And we call this step, the latter step, energy optimization. And this is, I'm sorry to say, a never-ending story. We know one thing for sure, and that is that leaks will come back and new ones will occur as long as machines and human beings are in motion. The only way to keep a sustainable energy optimization and stay in control is to monitor and continuously act on deviations from the set target levels. When we present the initial report, we present a report that is very dense and very filled with details. And for most people, the level of detail is, I would say, flying over their head. And we realized this, so we decided to make an infographic that is highlighting the main KPIs. So now we are presenting the report in an easy to consume way. We are looking at the operational hours, we are looking at the total volume, we are looking at the cost in different dimensions. So, for instance, how much energy is consumed? What is the energy cost consumed to drive the compressed air system? What is the total cost of the compressed air system if you include investments in compressors, depreciations, condensate, handling of drying of the air, and maintenance, of course. We're also looking at the generation efficiency indicator, which is a way of checking how much energy do you need to generate a cubic meter of air. So how efficient does the compressors work together? And we are, of course, looking at the savings potential and looking into the leakage levels and whether that is on a good level or not. And as said, this is all presented in an infographic that is presented as a front page to the more detailed report. With this, I think it was everything from X-ray from now, and I will hand over to Rebecca. The stage is yours.
Thanks, Anders, and hello, everybody, and welcome to the lab release presentation. In the following slides, I will talk about our new portal that R&D has developed, how it works, and how to become an early adopter to try it out. Our research and development team has increased. We are now focusing the work into the creation of the second generation of compressor services for the release next year. But already now in December, we have launched a lab version of a brand new portal for customers and partners. The idea behind the portal is to improve the data collection process as part of our three-step process. As Anders has explained before in his presentation, the new portal is the first part of our X-ray process. The portal allows us to collect feedback from key customers and partners and aims at streamlining the critical process when the customers fill in information about their compressed air system. We have realized that the collection of the data is a really complex process for different reasons. That's why our research and development team is now focusing their work into develop this portal. We want to provide a clear and user-friendly interface to make that part of the process efficient and as simple as possible. And with the portal, the users can now find the different forms and add their data in our system. And once they will have added and published the data, it will be reviewed by our experts. So by using our portal, you as a user can get a better understanding of your compressor system through our feedback. And if we continue talking about users, we can also tell you that in our development team, we have defined 3 different personas that they are going to be our main users for this new portal. They are the customer technicians, the partner salesman, and our experts. The idea behind this is to let the portal tie together all our users, and we want to develop different interfaces regarding the user needs to ensure the best possible user experience. So we are really happy to present our lab release of the new portal, and some of our goals with the release were to get alignment across the new R&D team. This is the very first thing that Enersize does with the new R&D team. We also wanted to set an anchor point to measure the success of our launch functionalities. And the lab release is not a feature complete release, but it reflects the software potentialities and provide a real environment for in-house testing, which is really important. And regarding the users, this lab release is allowing our clients and partners to get the look and feel and to test it out. And we are always open to receive feedback also to improve the products. And now we would like you to give you a little tour in the portal. Here you can see how you can add your compressed air system with some of the properties that we think they are important to understand how your system works. And once you have added your compressor system, you can add, for example, compressors to your system. You can choose compressors that are in our catalog, so you can see our brands and models, or create a new ones if we don't have them. And if you choose a model that we already have in our database, it will populate some of the data. And this data is verified. So it makes all this process more easy, and it reduces the risk of making mistakes in this kind of properties that are really, really sensible. So in the future, of course, we would like to increase the number of functionalities of this portal, like giving the user the possibility to add more elements like dryers, receivers to their own system, and we will allow, for example, also user experts, as I said, to give feedback to the user data and guide them into understand better their compressor system. So stay connected to our newsletter to know more about when this future release are going to happen. And of course, if you want to test our product, you can write us here to this email, and we will give you instructions how you can try the portal. And I would like to finish this presentation just inviting you to check our lab release website, and please give us feedback if you want. And now I will hand over to Anders, our CEO. He will continue talking about the Enersize development. Thank you.
Thank you, Rebecca. Now let's move over to how Enersize is approaching the challenge of implementing permanent monitoring of compressed air. My name is Anders Sjögren. Implementing Industry 4.0 and compressed air monitoring is often a challenge. There can be a lack of resources, a lack of know-how, and many solutions offered by suppliers are proprietary, effectively limiting your freedom. At Enersize, we are tying together real-time data from the factory floor with the flexibility of information technology. This slide from our technology partner, Sigma Industry Solutions, show us what we are dealing with. Interoperability from the factory floor, also called operational technology, OT, to information technology, IT, is for many a challenge. Until now, Enersize has had its own proprietary solutions for acquiring and managing real-time data. We have identified a set of themes to guide Enersize investments. In my presentation today, I will focus on the theme open standards, because it directly influences your possibilities to integrate compressed air services into your digitalization platforms. At Enersize, we are in the process of changing the way we work to deliver better quality, using open standards to lower the investment for you while increasing the flexibility, and streamlining the process of implementing permanent monitoring of your compressed air. And therefore, we are doing two major changes in how we work. First, we are focusing our business even more. We continue, of course, to deliver efficiency, energy efficiency to compressed air systems, but we also outsource to experts on real-time data collection on the OT side. Sigma Industry Solutions, who is part of the Sigma Group with 5,000 employees in 13 countries, is an ideal technology partner to Enersize. And second, with the help from Sigma Industry Solutions, we are standardizing the basic setup of monitoring equipment. At Enersize, we are experts at sensing compressed air, how to select the proper flow meter, how to configure it, how to install a dew point sensor, etc. But we're also developing our compressed air services in the cloud, aiming to become the global leader in software for energy efficiency of compressed air. Sigma, they are implementing communication solutions, including IoT, and together we can deliver a plug-and-play solution for compressed air monitoring. And using open standards such as Modbus, MQTT, and RESTful APIs, we maintain interoperability. We are still in the pilot phase and looking for early adopters. So if you feel that you're ready to start optimizing your compressed air system using our end-to-end solution, be sure to let us know. Thank you very much for listening.
Thank you very much for this update, Rebecca and Anders. It is exciting to see what is being built and also to understand how important Enersize see the engagement from customers and partners in the development work. I will now look at some tools and activities available to increase an interest for energy optimization of compressed air. And the first area I want to highlight is the Enersize web. This is actually a great resource for learning. And my favorite area is the Enersize Bootcamp. Here you can learn about compressed air, and when you feel ready for it, you can also take a quiz to test your skills. And talking about skills, I now want to hand over to Johannes Olsson, who is heading up Enersize Academy. So please bring it on, Johannes.
Thank you, Anders. Yes, let's take a look at Enersize Academy. So Enersize Academy, we divided it up in two parts actually. We have one theoretical, on-demand, online training experience that is followed up by the practical training that is performed on-site at customer projects. So we did this because we want a partner to be fully introduced to what we do and what they will be help us doing to our software products, tools, and work methods before we meet on a site. The practical training then is more hands-on, learn by doing. So we use the Moodle learning management system that is open source, and we can use it as a plugin. And it's a platform for creating educational material online. It looks like this. It's on brand. This is the login screen. We can enroll students, introduce them to the required courses, and monitor them throughout the entire learning experience. We can have them do quizzes and exams to check their knowledge level, and then certify them as an Enersize partner. It is available in over 200 countries and 100 languages. So after the student is enrolled, they are presented with a dashboard, which is the home screen, and here they are presented with all the required courses and exams. Let's take a look. We click on a course and we are presented with all the lessons in this course. We can take the safety check. Here we will come to a video lesson.
Make sure to always keep regular contact with the local staff to keep you updated on factory events, when equipment is turned on and off, and other needed safety measures. When there is moving machinery, take special care and ask when it's safe to enter the area to do the survey.
So after each course, there's a quiz to check the knowledge level, to keep the student on their toes and more involved. And then when that's done, they can move on to the next lesson. And wherever they are, they can always click the big orange button here to get back to the dashboard. And that's it for me. Thank you.
Thank you, Johannes. That was really great stuff. And last time we talked about the Enersize Advisory Council. And I can say we have now been running our first physical meeting with international experts and representatives from the industry to guide us as we develop. From the discussion, we could see that sustainability topics are now on top of the agenda in all companies. Real projects, ambitious objectives, and transparent follow-up. We also heard that the European Green Deal is making an impact, together with other initiatives like the Agenda 2030 and the recent COP26. Interesting is that production in low-cost countries is less attractive, as the carbon footprint for running the operation is often higher, and customers are asking for the life cycle impact when buying products. And this is all moving production into new countries. We also learned that there is a need for someone to take on the task to do real-time analysis of the compressed air system to predict maintenance and predict operational threats. What a great task for Enersize. So more about that later. If you have an interest in the topics we have discussed here today, you should of course sign up for the newsletter if you have not already done so. And the next newsletter that we are releasing is coming out on the 25th of January. So please make sure to be there. Last time we also mentioned the Share Your Story community as an important part of the overall Enersize Collaboration Lab initiative. Different activities that we are running to work closer to customers. And as you could see in Rebecca's presentation, we are developing a customer and partner portal as the first proof point for this initiative. With this, I just want to thank you all for participating in this webinar. The next webinar we are planning is being launched March 15 and 16. Until then, I wish you a great holiday, stay safe, and have a wonderful life. Bye.